All right, so we're supposed to find the optimal solution of the dual problem, and then we're supposed to find the optimal solution to the minimization problem. All right, so two things. They give us everything here, but do we understand how we get to those pieces? So this is what we're originally given. If we're given a problem, we're going to be given this first piece. And then what we do is we convert this from greater than or equal to the less than or equal to, going from A to A transpose and that. And so let's go ahead and do all the steps so we don't get lost along the way. So this is going to be a 3, a 5, and a 30, and a 2, a 3, a 19, and then a 16, a 25, and a 1. And so that would be our A matrix, again, x1, x2. Then we do A transpose. So basically, the first row becomes the first column, second row becomes the second column, and then the third row becomes the last column. And so this becomes y1, y2, and hence 3y1, 2y2 is 16, and it's less than or equal to, and then 5y1 plus 3y2 is less than or equal to 25, and then it's the 30y1 plus 19y2 is going to be our p. And so we've converted from a minimization to a maximization by converting from the greater than to the less than or equal to. And from this, now what we've done is we've said, okay, well, here from A transpose, we got to this maximization. And then after that, we said, okay, well, that's going to be, we have to add some slack variables. So then we did a 3y1 plus 2y2 plus x1 equals 16. And we did a 5y1 plus 3y2 plus x2 equals 25. And we took everything to the other side. So minus 30y1 minus 19y2 plus a p equals 0. And y1, y2, x1, x2 all are greater than or equal to 0. And so then we had 3, 2, 1, and all that. When we converted all this into a problem. And so then when we did the problem, we had to work it all the way down until we get to this stage. So this is actually the very last step of the problem. And so what we're going to do is we're going to figure out how did we go from here to get to this very last stage. Well, okay, so what we had to do is we had to put it into a tableau. And so we had a 3, a 2, a 1, a 0, a 0, and a 16. This is y1, y2, x1, x2, p. And this was x1, x2, and a p. And so then we had a 5, a 3, a 0, a 1, a 0, and a 25. We had a minus 30, minus 19, a 0, a 0, a 1, and a 0. Okay. And so what we need to do now is, and again, the problem is not set up to do all this. This is already given you the answer, but what we want to do is figure out to make sure we know how to get to that answer. And so now we look, that's our smallest, our largest negative number, I should say, or the smallest, number overall, because it's the most negative. And so that means we're going to take, for our quotient, we're going to take 16 divided by 3. And so that's going to be what? 5 and a third. We're going to take 25 divided by 5, which is a 5. And so this is the smallest. So this is going to be our pivot point. So we're going to enter here and we're going to exit here. And so now what we need to do is we need to take 1/5 row 2 and make that the new row 2. Okay. Now, I could take a negative 3/5 row 2 plus row 1, and that's my new row 1. And if I take 6 times row 2 plus row 3, that's going to be my new row 3. Okay. So now I'm going to go and put that onto the next page, what that turns all out to be. Now, again, we have y1, y2, x1, x2, then p, and then we have a line, and then we entered the y1, and so we have x1, y1, and a p. And so we have 0, 1/5, 1 minus 3/5, 0, 1. Then we had a 1, a 3/5, 0, 1/5, 0, and then a 5, and we had a 0, a -1, a 0, a 6, a 1, and then that ends up being 150. All right, so now we look at the most negative, it's that one. And so we're going to take, in this case, the quotient is going to be 1 divided by, and that's 1/5, so that's going to be what, 5. And here we have 5 divided by 3/5, and so that's going to be what, 25 over 3. So this one actually is the smallest, so that means we're going to work with that one as our pivot point. So we're going to enter here, and we're going to exit here. Okay. So when we do that, what are we going to do? Well, I need to take 5 times row 1 and make that my new row 1. If I take a -3 row 1 plus row 2, that's my new row 2. And if I take a 5 times row 1 plus row 3, that could be my new row 3. Okay. So again, what we're going to do is we're going to make that first one a y2, and so now we'll have a y2, we'll have a y1, we'll have a p, and again, these are y1, y2, x1, x2, p, and then we have all that. So if we multiply that first row by 5, we have a 0, a 1, a 5, a -3, a 0, and a 5. And if we, so 3 times that, so that's going to be a 1, a 0, a -3, 2, a 0, and that's going to be a 2. And then 5 times that's going to be a 0, a 0, a 5, a 3, a 1, and 155. Okay. So for this, this is what do I call it? The maximization problem. And so this is really what we've just solved here is that. And so then what we could say is, if we let x1 and x2 equals 0, y2 is equal to 5 going across, and y1 is equal to 2, and the max p is equal to 155. But really, what they want us to do is minimize. And so the minimization c is going to be 155. And so now what we have to do is we're going to have to go down. So really we want the actual values for x1 and x2 because we don't care about the y1 and y2 because those are kind of the we transposed it and all that stuff to get to those values. We want the original x1 and x2. That's where we're actually looking for. And so that's going to be kind of the key here. And so that goes down. So we have to read down here. So x1 is 5 and x2 is equal to 3, and that's oh, I already have min c up there. Never mind. All right, so that would be really the key thing there. So have we answered everything here? Find the optimal solution of the dual problem. Yeah, we found the dual problem. Find the optimization of the minimization problem. Yeah, we've done that. So this would kind of be more like the A over here on the left, and B is kind of this part here. So that's really kind of the B, and this is our A. And so this is kind of the final answer really that we'd be looking for in this case. All right, so let's stop there and we'll come back for some more.